Alright guys, today we're going to be looking at golden rectangles and see if we can do something with those. Here's our problem. Given a golden rectangle, and I have that drawn there in the green, if we put a circle inside that, the largest possible circle, so that it touches 3 of the 4 sides, and it's going to be touching 2 sides that are opposite, just that is shown right there on the screen. If we connect the 2 points where it touches the opposite side, so if we connect from here to here and cut along that line, so to speak, so that we have 2 separate smaller rectangles, will either of those rectangles be a golden rectangle? So that's what we need to look at and solve for today. First thing I want to make sure that we're comfortable with is, what is a golden rectangle? Well, a golden rectangle is when we take the ratio of the base divided by the height, it's going to give us phi. Okay? And phi is, more specifically, if we wanted to give it a number, is going to be 1 plus the square root of 5 over 2. Okay, that's what phi equals. So before we can decide if either one of these 2 smaller rectangles is a golden rectangle, we got to put some measurements to our golden rectangle that we have. And so let's just use the number phi that we have. So if we can apply 1 plus the square root of 5 to the base and 2 to the height, we can then figure out if we have 2 smaller golden rectangles. Alright, first thing that we need to do, just by looking at properties of rectangles, if this side over here is going to be 2, then over here is going to be 2 as well. So let's go ahead and write that in, because that'll be useful later down here, down the road. What we have left to figure out is, what are the lengths of these 2 segments here? What are the lengths of those 2 sides? Okay, well, to figure that out, we can look at that circle that we have, the largest possible circle inside that rectangle. And if we're looking at the line that we have drawn, it's going from one edge to another edge, and it's going to go through the center here. So what happens, this was our center here, what happens is that's going to give us a diameter. Okay, well, if I'm going to just draw another line in here just to give us a visual of what's, oops, let me try that again. There we go, that looks better. Okay, it's pretty close, but if that line is right there on the outside of the circle, so that it's just tangent to it, notice then we have a square, okay? Because if we go from one side of the circle to the other side, passing through the center, that gives us another diameter. And this line right here, there we go, if we draw that in so it meets both sides of the rectangle at a 90-degree angle, that of course is then going to give us a length of 2. So we can see that if we're looking from just here to here, that's the length of the radius, because that's going to be half of the diameter from the center to the outside of the circle. So if the diameter is 2, the radius then has to be 1. And so let's go ahead and write a 1 down there. We've solved that that segment is 1. Well, knowing that, we can solve for this other edge here and see what that equals. If this whole base of our golden rectangle is 1 plus the square root of 5, we can set that equal to the 2 pieces down here, so we can set it equal to 1 plus, let's just give this unknown length here a variable. Let's put in x there, and we can solve for x. So let's just start by subtracting 1 from both sides. When we do so, we now see that the square root of 5 is going to equal x. So that length there is the square root of 5. Okay? So now that we have our lengths, we can determine, are these either one of these 2 smaller rectangles, are they golden rectangles? Okay. Well, again, reminder, a golden rectangle is when you take the base over the height, is going to give us the ratio of phi, which we've said already. Phi is equal to 1 plus the square root of 5 over 2. So if we set those equal to it, those ratios, and cross multiply, we can see if these two ratios are proportional. Okay, let's look back here to our rectangles here. Let's first identify whether or not this smaller rectangle here, in my picture at least it's the smaller one, equals a golden, or is a golden rectangle. So looking at that, we have dimensions of 2 and 1. 2 is going to be our base since it's the larger number. 1 is going to be our height. So let's go back and fill that in over here. So if we take our base of 2, oops, there we go, our base of 2 over our height of 1, is that proportional to 1 plus the square root of 5 over 2? Well, cross multiplying, we get 4 equals 1 plus the square root of 5. Just doing some solving, see if we can possibly get it to equal. If we subtract 1 from both sides, we get 3 equals the square root of 5. Right? Well, that is not a true statement. That is incorrect. So that smaller rectangle that we created there is not a golden rectangle. Base over the height does not equal phi. Okay, so let's look at the other one. We have a 2 as one length and a square root of 5 as another. So again, our largest number is going to be our base, which in this case it's the square root of 5. So we're going to write in the square root of 5 over a height of 2. Is this proportional to 1 plus the square root of 5 over 2? Okay, so we're going to cross multiply again. 2 square root of 5 equals 2 plus 2 square root of 5. Doing some work, seeing if we can simplify this a little bit. Subtracting 2 square root of 5 from both sides. Those cancel, we get 0 equals 2. So this is not, these two ratios are not proportional, so that means that our other rectangle that we have in here is not a golden rectangle either. So when we put in the largest possible circle into a golden rectangle, and we make a line from where it intersects or where it touches both opposite sides of our rectangle, and we look at those two smaller rectangles, it does not create two smaller golden rectangles.